The freshwater ecosystems that have long been a source of life on Earth are now in the midst of a quiet but dangerous crisis. A groundbreaking study led by researchers at Utrecht University reveals a critical shift in how oxygen is produced and consumed in rivers, lakes, and reservoirs. These vital water sources are suffocating, not from a lack of water, but from a lack of oxygen. The findings, published in Science Advances, show that human activities during the Anthropocene have drastically altered the global oxygen cycle in freshwater systems, tipping the balance from oxygen production to oxygen consumption. This shift is not a small or local problem. It is a global emergency with far-reaching implications for both the environment and human society. Freshwater bodies, from the smallest streams to the largest lakes, are critical not only for sustaining aquatic life but for maintaining the health of the planet. Oxygen is a central element in nutrient cycles like carbon and nitrogen, and any disruption to its availability can set off a cascade of harmful effects. As oxygen levels drop, leading to hypoxic conditions, ecosystems begin to break down. Fish die, food webs collapse, and water quality deteriorates, all of which can have devastating consequences for the environment and the communities that depend on these water sources. These changes are already happening, and the impacts are being felt worldwide, from the fishing communities in Southeast Asia to the agricultural regions of the American Midwest. The study developed by Utrecht University researchers presents a new model that tracks the global oxygen cycle in inland waters. This model is a crucial step in understanding the complex processes that govern how oxygen is used in these ecosystems. For the first time, scientists have been able to comprehensively map the oxygen turnover in freshwater systems on a global scale. The results are stark. These ecosystems are consuming more oxygen than they produce, creating a growing oxygen sink in our rivers and lakes. This shift is happening at an alarming rate, and if left unchecked, it could worsen in ways we may not fully comprehend yet. Human activities, particularly agriculture, wastewater management, dam construction, and global warming, are driving this acceleration of oxygen depletion. The increase in nutrient pollution, particularly from overfertilization, has fueled algae blooms that, when they die and decompose, consume vast amounts of oxygen. Dams and reservoirs, by altering the natural flow of water, have also contributed to slower oxygen exchange, making it more difficult for freshwater ecosystems to recover. While rising temperatures exacerbate the problem by reducing the solubility of oxygen in water, this factor is less significant than originally thought, contributing to only about 10 to 20% of the acceleration in oxygen depletion. Instead, the primary culprits are direct human activities that have intensified over the past century. The magnitude of this crisis is hard to ignore. Freshwater bodies, though they cover only a small fraction of the Earth's surface, now account for the loss of nearly 1 billion tons of oxygen from the atmosphere each year. This is half the amount that the entire ocean emits back into the atmosphere, underscoring the growing importance of inland waters in global oxygen and climate budgets. What we once considered a relatively minor part of the Earth's biosphere is now a central player in the global ecological balance. In light of these findings, the urgency to address the degradation of freshwater ecosystems has never been more pressing. While the problem has been exacerbated by decades of human activity, the good news is that this issue is not beyond repair. By reducing nutrient pollution through better agricultural practices, improving wastewater management, and re-evaluating how we build and manage dams, we can begin to slow the acceleration of oxygen depletion in freshwater systems. Additionally, tackling global warming by curbing emissions will help maintain the solubility of oxygen in water and slow down the processes that consume it. This study serves as a wake-up call, reminding us that the state of our planet's freshwater systems is intrinsically linked to the health of the entire biosphere. The changes we have made to the Earth's natural processes are now coming to a head, but with concerted global action, it is possible to reverse some of the damage. Freshwater systems are too vital to ignore. They are a linchpin in the delicate balance of life on Earth, and we must take immediate steps to protect them before the damage becomes irreversible.